Hello class. So today we're going to be talking about converting angles. And we're also going to talk about objective 5, which is going to be coterminal angles in radians. So to get started, I have two angles, one in degrees and one in radians. And let's say we want to convert this one to radians and this one to degrees. So how are we going to accomplish that? Referencing last video, we figured out that 360 degrees was equivalent to 2 pi. So we're going to simplify that a bit by dividing by 2. Now we're going to have something like this. 180 degrees is equal to pi. Now, how are we going to use this equation in converting these angles? Well, I want you to know that when you have any kind of measurement, let's actually write this on the side. So if you have any kind of measurement x, and you multiply it by 1, you get the same measurement back. But this 1 can take any form that you want. It can be 3 over 3. It can be, if it's different measurements, like 1 inch and a foot, right? We'd have, or 12 inches and a foot, we could multiply by 12 over 1 if this is in feet, and we'll get the answer in inches. So that's how we're going to use this relationship. Now, if we look at our examples that we've written down, so theta equal to 45 degrees. Well, we're going to multiply it by 1, but our 1 in this case is going to be pi over 180 degrees. Whenever you are trying to change the units of some measurement, you want to make sure that you divide it by the entity that has the same measurement. So this 45 degrees, if I were to multiply it by 180 degrees, that wouldn't get rid of the degrees and give us something in radians. But if I divide by the 180, then we cancel out the degrees measurement, if you will, and we get something in radians. So when we do this multiplication out, we're going to get 45 over 180 pi, and then simplifying this expression, we get theta equals pi over 4. And that's going to be our angle that is equivalent but is in radians. Now, looking at the opposite side, we have theta is 2 pi over 3. Again, we want to multiply this by 1, but we also want to cancel out the radians measurement. So we're going to take the same exact proportion that we multiplied 45 by and just flip it. We're going to take the reciprocal of pi over 180, which is going to be 180 degrees divided by pi. So as some of you may notice, you can cancel out the pi here. And also, when simplifying, you can see that 180, right, can be divided by 3 to 60. So we get theta equals 2 times 180 over 3 times pi over pi. I'm just kind of writing this out to show you how things simplify. And then this goes to 60. And this is equal to 1. So then our final answer is 2 times 60, which is going to be theta is equal to 120 degrees. And now we have two equivalent angles that equals 120 degrees, and theta equals 2 pi over 3, but they have different units. And this is all that it takes in order to convert angles between degrees and radians. The key is to make sure you have the right proportion And the way you remember it is that you need to divide by whichever one has the same units as your original theta. Okay. Now that we're done with converting degrees and radians, I want to mention coterminal angles in radian measure. So what I have written out here is what we learned in objective 2, which is if you're given an angle theta, then theta plus k, where k is just some non-zero integer, times 360 degrees is coterminal, right? And maybe I should write here to original theta. Okay, so if given theta, then theta plus k times 360 degrees is coterminal to original theta, or to the original theta. Now, how do we translate this into radians? Well, again, we have the proportion pi over 180. So we can go in and use this proportion and just plug this into here to try to find, sorry, this is a messy arrow, but it's supposed to be an arrow. We can just plug this into here to find our radian coterminal angle. And what we will end up with when we do that, let me just write that off on the side. So if we plug that in, then we have theta plus k times our proportion pi over 180 times 360. And 180, or 360 divided by 180 is 2. So all we have is theta plus k times 2 pi. Theta stays the same, k stays the same. The only thing that changes is what we multiply k by. So our statement then is if given theta, then theta plus k times 2 pi is coterminal to theta. And that's it. So now we have the coterminal angles in a radian measure given some theta. And that's it for chapter 6, section 1. That should be everything. Again, let me know in the comments down below if there's anything I can add to these, or if there's any additional questions, examples, or I guess problems that you would like me to cover. All right, guys, thanks for watching, and I'll see you next time.